All right. So today we are classifying polygons again, but we're classifying quadrilaterals. Let's start off with our I can statement. So I can use slope relationships to identify parallel and perpendicular lines. And I can use midpoint and distance to calculate lengths of sides and bisectors. Okay. So we said when we started our card sort today, we said that a quadrilateral is just a polygon with four sides. And then we broke it up into some very specific types of quadrilaterals. You need to be able to identify three. It is the Math 1 standard that you can identify three types of quadrilaterals. Number one is a parallelogram. Number two is a rectangle. And number three is a square. Those are the only ones that you need to worry about. So we know that if we have a parallelogram, we know something very specific. We know that we have opposite sides are parallel. So you have two sets of parallel sides. And you would use slope to do that. That is one method. Okay. The other method, the easiest one, I believe, is to use the midpoint formula to show that the diagonals bisect each other. This one is so important that this would be my number one choice every single time. Why? Well, because the midpoint is easy. It's an addition problem. And you just show that they have the same point. They bisect means that they intersect at the same point. So you would use the midpoint and show that the diagonals have the same midpoint. That is my number one choice. I would always use that. Okay. There are three ways to do it. I would only use that one I highlighted every single time. Midpoint is easy. What is the midpoint formula?
1x1 plus x2 divided by 2, y1 plus y2 divided by 2.
Yeah, it's just an addition problem, right? So you're going to have to find the midpoint of each diagonal. And if they're the same, then they bisect each other. That is what I would use every single time. Let's draw a picture so you have an understanding of what that means. So I'm going to draw a sketch of a parallelogram. I'm just going to draw a sketch. It doesn't have to be perfect. So if the diagonals bisect each other, this is one diagonal. This is my other diagonal. If they bisect each other, that means that they intersect at the exact same point, meaning that their midpoint is the same. This number right here, this place, whatever it is the same. It's the middle of the orange line and it's the middle of the green line. Okay? Use that method. It's the easiest one. Just show that they have the same midpoint. Because if they don't, it's not a parallelogram. And if it's not a parallelogram, then it's not a rectangle and it's not a square. Done. Okay? So what method are you going to use? Midpoint. Yeah, use the midpoint. Show the diagonals bisect each other. Once you show that it's a rectangle or a parallelogram, then you need to show that it's a rectangle. And here's the method that I would use. I would use the distance formula to show that the diagonals are equal. I wouldn't do anything about perpendicular lines because you'd have to show that all four sides are perpendicular to each other. All adjacent sides make right angles. Don't do that. Just show that the diagonals are equal to each other using the distance formula, and that means it's a rectangle. What is the distance formula, Aiden A? Open your eyes, pay attention, get your head up off your hand. Distance formula, D equals the square root of, parenthesis, x sub 2 minus x sub 1, the quantity squared, plus, parenthesis, y sub 2 minus y sub 1, the quantity squared. That's what I would use every single time. That's the easiest way to do it. If you have a parallelogram, the first thing I would do is check and see if it's a rectangle. If it's not a rectangle, can it be a square? No, because we learned from our sorting that if it doesn't meet the qualifications for a rectangle, then there's no way it can be a square. So you're done. Okay? But if it is a rectangle, then you got to check and see if it's a square. If it's a rectangle, you got to check and see if it's a square. How are we going to do that? Yeah, who said slope? Who was that? Awesome, Daniel. This is the method that I would choose. I would use slope to prove that the diagonals are perpendicular. I don't care about the measures of the sides because that's 4 things that you have to calculate. You have to use the distance formula 4 times. That's tough. Or you can use the slope twice to show that the diagonals are perpendicular to each other. Because if they are, then it's a square. Okay? What is the slope formula? I forgot. Perfect. Are these other ways or methods important? Yeah, they can help you, but I would only use the most precise method, the easiest way, right? We all want to do stuff the easiest way. Let's use the quickest method to prove what we need to prove. Okay? Questions about that? Okay, so let's do an example together. I'm not going to do this yet. We'll do this tomorrow. Let's do example number 2. It says, determine whether the given vertices represent a parallelogram, a rectangle, or a square. So the first thing that we have to do is plot the points. Plot and label the points. That's the first thing that we're going to do. Okay, so E is the ordered pair 2, 1. F is the ordered pair 3, 4. G is the ordered pair 7, 2. H is the ordered pair 6, -1. I'm going to connect my points to create my shape. I'm going to connect my points to create my shape. Okay. Okay. So now we need to show that this is a parallelogram. How are we going to show that this is a parallelogram? What method did I say I would always use? Yep, using the midpoint of the diagonals. Okay, so let's see. What are my diagonals? Well, I have FH and EG. So let's see. The midpoint of FH. So I'm using 3 plus 6 divided by 2 and 4 plus negative 1 divided by 2. Well, what is 3 plus 6? It's 9. So I have 9 over 2, and 4 plus negative 1 is 3. 3 over 2. I know 9 over 2 is an improper fraction. I don't care. If they have the same midpoint, the other one will have the same improper fraction. So just go with it. Now let's calculate the midpoint of EG. So E, 2, the x-coordinates, 2 plus 7. 2 plus 7 divided by 2, comma, 1 plus 2. 1 plus 2 divided by 2. Well, 2 plus 7 is what? 9. 9 over 2, and 1 plus 2 is? Oh my goodness. Do we have a parallelogram? Yes or no? Yes. So we need to say that. We need to say that E, F, G, H is a parallelogram because, oops, I didn't mean for that to change colors, sorry. Because the diagonals bisect each other. We just showed that the diagonals bisect each other because they have the same midpoint. That is the easiest method. Use it. So we've shown that it's a parallelogram. So that means it could be a rectangle and it could be a square, right? What's the easiest way to show that it's a rectangle? So that's what we have to do next. Use distance to show the diagonals are congruent, right? Isn't that what we're trying to show? That the diagonals have the same measure. So I have to find the distance of FH first. Okay, so let's see. I have to turn to mine because I don't remember what the order of pairs are. So let's see. FH, 3 minus 6, the quantity squared, plus the y coordinates. Sorry. 4 minus negative 1, which is the same thing as 4 plus 1 squared. Okay, well, what is 3 minus 6? So I have negative 3 squared plus, what's 4 plus 1? 5 squared. Okay, what is negative 3 squared? Negative 3 times negative 3 is 9. And 5 squared is? What's 9 plus 25? 34. Is that simplified? No. Do I care? No. Because if the diagonals are the same, I'm going to get the exact same radical, the square root of 34, for the other one. So let's calculate the diagonal of the length of EG. Okay. So let's see. E, 2 minus 7, the quantity squared, plus 1 minus 2, the quantity squared. What is 2 minus 7? Negative 5, and negative 5, so I have negative 5, the quantity squared, plus, what's 1 minus 2? It's negative 1. Yeah. What is negative 5 squared? It's positive 25. And what's negative 1 squared? Negative 1 times negative 1 is positive 1. So this equals the square root of 26. Are those the same? No, they're not. So what does that mean? That means that E, F, G, H is not a rectangle because the diagonals are not equal. So if it is not a rectangle, should we go ahead and try and prove that it's a square? Can it be? No, it cannot. So the only thing that we can say about this is that E, F, G, H is a parallelogram. That's the only thing that we can say.